Dear students, welcome to the lecture series on the topic Engineering Graphic. Today we are going to discuss about projections of the oblique lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. An oblique line is the one which is inclined to both the reference planes, that is horizontal plane, as well as the vertical plane. So due to the inclination of the oblique line with the two reference planes, so neither of the front view or the top view, they will be parallel to the XY reference line, and we are going to obtain the apparent length projections of the line onto the horizontal plane as well as the vertical plane. So we will not be able to obtain the true length of the line either in the front view or in the top view projection. So in case we are required to evaluate the true length of the line alongside the true inclinations of the oblique line with respect to the two reference planes, so we will be required to use the principles of rotation of the line to evaluate these parameters. So here we have been provided with a real life situation in which a picture frame which is measuring 2 meter width and 1 meter height. So this is the picture frame which has been mounted onto the wall and it is resting on the wall on a railing. So we can see this is the railing which has been shown over here. So onto this horizontal railing, this picture frame is resting onto the wall, and this picture frame happens to be inclined at an angle of 35 degree with respect to this vertical wall, right? So this is the vertical wall, and this picture frame, it is making an angle of inclination that is 35 degree with respect to this wall, and this picture frame is secured to the wall with the help of these two chains. So these are the black chains that we have shown over here, and there is a hook. So onto these two corners of this picture frame which is measuring 2 meter width over here, so the two hooks, they have been mounted on the either side of the width of this painting, and with the help of this chain which is mounted centrally over here, so this hook is secured to the wall. So using these two strings or the chains, so this particular picture frame has been secured to the wall, right? So now the objective is that we are required to evaluate the length of this chain, that is true length HA and HB, and we must understand that HA should be equal to HB, and we are also required to evaluate the true angle of inclination between these two chains, that is HA and HB. So this is the included angle between these two chains we are also required to evaluate. So first of all, we will be converting this real life problem into the orthographic projections of the oblique lines, and thereafter we will be using the principles of the rotation of the line to evaluate the true length of this chain HA, true length of this chain HB, and the included angle between these two chains HA and HB we will also be evaluating. So let us first of all start with the construction of the orthographic projections of this particular object. So to begin with, we are going to start with the conversion of this real life problem into the orthographic projections of the oblique line. Thereafter, we will be using the principles of the rotation of the line to evaluate the true length of this chain HA and HB, and besides this, we will also be evaluating the included angle between these two chains HA and HB. Now here we have got the XY reference line. Now once we draw the XY reference line, we know that this is the wall onto which this particular picture frame will be secured over here, and we know that this picture frame, it is resting on the wall railing. So this is the horizontal wall railing which has been shown over here into this picture over here. Now this wall railing we have marked over here. So as we are going to look at this particular picture frame from this side as the front view, so we can see that points C and D, which are corresponding to the bottom line of this particular picture frame, which is resting onto this wall railing. So these 2 points C and D, so they will be coinciding with each other as we are going to look at this picture frame from this particular orientation. So in the front view we are going to observe C dash and D dash, and these 2 points they will be located onto the wall. So onto the wall these 2 points they will be located, and these points C dash and D dash, so they will be observed just above this particular wall railing which is shown over here. So we will assume that onto this wall railing these 2 points C dash and D dash, so they are located over here. And now looking at this real world environment, now we can see that the height of this particular picture frame happens to be 1 meter. So we are going to use the scale of 1:25. That is 1 meter will be represented as 4 centimeter or 40 millimeter over here. So since this is the height of the picture frame which is available with us as 1 meter, so the length of the picture frame which we are going to draw into this orthographic projections, it will be 40 millimeter, and this height which is corresponding to the distance C dash and B dash, and this is inclined, the surface is inclined at an angle of 35 degree with respect to this wall. So as we look at this picture frame from this orientation, we will find that we are going to get this picture frame inclined at an angle of 35 degree with respect to this wall, and this length of the picture frame we are going to mark as 40 millimeter. And another thing we know that the vertical distance between this hook and the bottom of this wall railing, it happens to be 1.5 meters. So corresponding to this vertical distance between the bottom of this railing and the hook location, now hook is located onto the wall, so hook will be located over here. So as we look at this particular environment from the right hand side, we'll find that H dash point which will be corresponding to this hook which is located onto the wall. So this will be available with us at a height of 1.5 meter or 60 millimeter above the location of this railing point. So the railing point C dash D dash we have already marked. Now this H dash point has also been located, which is corresponding to the location of the hook, and this hook is secured to the wall over here. So H dash will be located in the same vertical orientation where the wall railing was located over here. Now having located C dash D dash in the front view, now points B dash and A dash, so A dash and B dash, so they will be located in such a way that the height of the painting will be 1 meter, that is 40 millimeter, and this length of C dash and B dash, so this will be oriented at an angle of 35 degree with respect to this wall. So from C dash and D dash, now we are going to draw a projection line which is going to measure 40 millimeter, that is 1 meter height of the picture frame we have been able to draw, and this we have drawn at an inclination of 35 degree with respect to the vertical wall. Now wherever this construction line which is measuring 40 millimeter, so this will end, so we can mark points A dash and B dash over here. So here we have marked the points A dash and B dash, and now we can check these are the two strings corresponding to which the true lengths need to be evaluated. Now these strings, they are located on the top of the picture frame, that is on the top of the picture frame these two hooks, they have been mounted over here. So with the help of these strings, so we have secured the picture frame using these two hooks onto the wall. So now we need to join H dash with A dash B dash, and this we have shown with the help of red color. So the red color means that this is the location and orientation of the two chains, and in the front view HA and HB, both of these chains, since they are going to overlap or coincide with each other, so that is why, so the projections H dash A dash and H dash B dash, so they have coincided with each other. So this way the front view of the picture frame A dash, B dash, C dash, D dash and the hook, that is H dash projection, they have been obtained. Now we will proceed with the construction of the top view projections of this particular picture frame as well as the hook. Now we also know that this is the width of the picture frame. So the width of the picture frame happens to be 2 meters. So as per the scale 1:25, so 2 meters will be represented as the distance 80 millimeter in the top view projection. So in the top view, we have marked this distance corresponding to the width of the picture frame 2 meter as 80 millimeter. Now having marked this distance, now we can go about construction of this picture frame. Now as we look at this particular picture frame from the top, so we will find that points C and D, they will be located onto the wall, because the picture frame is resting onto the wall, onto this wall railing. And we also know through the principles of projections of the line, that is wherever points A dash and B dash they are lying, onto this vertical projection line points A and B will be lying. Similarly, wherever points C dash and D dash and H dash they were lying, onto this particular vertical projector line we are going to observe the location of the plan projections corresponding to the points C, D and H over here. Now we also know that C and D points, they are lying onto the wall, whereas A and B points, they are going to lie away from the wall. So as we look at this particular picture frame from the top, so we find that this is our point A and this is our point B, this is our point C and this is our point D, right? So these are 4 points A, B, C and D. So once we have, we can check if we are looking from the top. So closer to the wall, here we have point A. As we move along over here, we obtain point B, and then onto the wall we have got this point C, and then closer to this XY reference line we have got the point D over here. So this way A, B, C and D points, they have been located. And regarding the location of this hook, so we know that the length of the chain HA and the length of the chain HB, it should be equal, because this hook has to be located centrally in order to maintain the perfect balance of this particular picture frame over here. Because if these lengths, they are not equal, and if this point H, that is the hook, if it is not located centrally in the center of this width of 2 meter, so obviously there will not be the balance of this particular picture frame. So we want to ensure that this picture frame should be located perfectly secured onto the wall into the horizontal position. So this point H, that is corresponding to the hook, it will be lying in the middle of the width of this particular picture frame, that is 1 meter from point A and 1 meter from point B. So that is why, since H dash was lying over here, so as we move down, so this is the total width of the picture frame, which happens to be 2 meter. So at a distance of 1 meter from either side, so we have been able to locate this point H in the top view. Now we are going to join HA and HB using red color projection line. That is, again, these are the apparent lengths. So H dash A dash is the apparent length, H dash B dash is the apparent length, HA, it is the apparent length, and HB, it is also the apparent length. So H dash A dash and H dash B dash, they were the apparent length projections corresponding to the chain which were available with us in the front view, whereas HA and HB, these are the projection lines corresponding to the chain which are available with us in the top view projections. So now we have been able to successfully convert this real life situation into the orthographic projection. Now, using the fundamentals of rotation of the line, we will be evaluating the true length of the chains, that is HA and HB over here. So to begin with, we know that whenever the elevation projection in the front view A dash B dash happens to be parallel to the horizontal plane, so the projections drawn through these 2 points onto the horizontal plane will be providing us with the true length of the line in the top view or on the horizontal plane. So here we have got the elevation projection line H dash A dash and H dash B dash corresponding to the 2 chains, but this is inclined to the horizontal plane. So what we are going to do, we are going to rotate these 2 projection lines over here corresponding to the 2 chains HA and HB parallel to the horizontal plane. So here our needle point will be point H dash. We'll open the compass is equal to H dash A dash and H dash B dash and rotate this elevation projection line into this orientation up to the locus line of the point H dash. So the 2 points which we obtain, they will be A1 dash and B1 dash. So these points, they are pairing because of the intersection of the horizontal locus line appearing through the point H dash and the arc which we have drawn through the rotation of this elevation line H dash A dash over here. So once we obtain these 2 points A1 dash and B1 dash, now we have to draw a vertical projector line through these 2 points onto the horizontal plane. So wherever once again the intersection with the A locus line and the B locus line will occur, we will be able to obtain the true lengths of the chains HA and HB over here. So let us draw the vertical projector line through these 2 points A1 dash and B1 dash. Now you see these are 2 chains which were overlapping or coinciding with each other in the front view. So here we need to draw the perpendicular through these 2 points A1 dash and B1 dash onto the horizontal locus lines corresponding to the points A and point B over here. So now 2 intersections we need to obtain over here because these are 2 different points. So once we draw the vertical perpendicular projection from the points A1 dash and B1 dash, so wherever this projection line intersects with the horizontal locus line through the point A, we obtain the point A1. Similarly, wherever this vertical projector line, it intersects with the horizontal projector line appearing through the point B, we obtain the point B1. So having obtained 2 points A1 and B1 in the top view, now using blue color line, we are going to join HA1 and HB1 over here. So this is the true length of the chain HA. This is the true length of the chain HB. So HA1 will represent the true length of the chain HA and HB1 will be representing the true length of the chain HB. And having drawn these 2 true lengths, now if we mark the included angle between these 2 chains, so we will be getting the true inclination between these 2 chains in the top view. So this way we have been able to evaluate length of each chain as it was required and the true angle of inclination between these 2 chains. So this we have been able to obtain in the top view. But now we are also going to obtain the true length of the chains in the front view as well, because we have obtained the true length of the chain in the plan. Now in order to obtain the true length of the chain in the elevation, now we need to remember that whenever the apparent length of the projection in the plan, it happens to be parallel to the vertical plane, so the projectors that we draw through these 2 points onto the vertical plane, they will be providing us with the true length of the line in the front view. So here we have got the apparent lengths of this chain, that is HA and HB, which are equal to each other. So what we are going to do, we can pick up any one of these 2 projections, or you can rotate both of them to make it parallel to the vertical plane. So here we can see we have rotated this. So we have not shown this rotation because then it will lead to too many lines, but both of them, they will be converging at the same point. So once we rotate this apparent length HB, or even you can rotate HA or both of them. So even if you rotate both of them, you are going to get points A2, B2 over here. So up to which point you need to rotate? Up to the horizontal locus line corresponding to the point H. So point H will become our needle point. So we can open compass is equal to distance HB or distance HA. So through point H, we are going to draw the curve in such a way that we get the rotation of this apparent length in plan parallel to the vertical plane. And once we obtain this point, so name of this point will be A2 and B2 over here. So this point name will be A2 and B2. So once you obtain this point A2 and B2, now we have been able to obtain the apparent length projection in the plan parallel to the vertical plane. Now we need to draw the vertical projector through these points onto the vertical plane, and we will be able to obtain the true length of the line in the elevation as well. So through this particular point A2, B2, so if we draw the vertical projector line into this orientation, now once we extend this, we will find that we have to extend this vertical projector line up to the horizontal locus line corresponding to the points A dash and B dash. So from A to B2, we have drawn this vertical projector line upwards in such a way that this vertical projector line, it should be extended or intersecting with the horizontal locus line which is appearing through the points A dash and B dash. And wherever this intersection occurs, we'll be marking these points as A2 dash, B2 dash. And then again using blue color line, I can join H dash A2 dash and H dash B2 dash. Because these two chains, they are going to converge or coincide with each other. So the same true length will be available with us even in the front view. So the moment we obtain this true length, now we have to measure the distance that H dash A2 dash or H dash B2 dash. So the moment we measure these distances and work out that the true length of the chain in the elevation, it is equal to true length of the chain in the plan. So it means that we have utilized the principles of the rotation of the line in an appropriate manner, and the solution that we have obtained regarding the determination of the length of each of the chains, so it is correct. And we have also evaluated the true angle between the chains. So the true angle between the chains, it was evaluated in the top view projection. In the front view, we cannot see the true inclination between the chains because the two chains HA, we can see HA and HB, they are going to coincide with each other. So this included angle will be visible to us only in the top view projection over there. So this way we have been able to convert the real life problem into the orthographic projections of the oblique line, and then using the method of rotation of the line, we have been able to evaluate true length of the line in the front view as well as in the top view, and into this case we have also evaluated the angle of inclination between the two chains which was required to be evaluated. So this is all for today. So we'll be continuing with further discussion on few more topics of projections of the oblique lines in the coming lectures. So thank you very much. Thanks a lot.